Swayam Prabha. Digital India. Educated India.
Welcome back to the manufacturing automation series of lectures. Now, in our last session we discussed some of the important points about the feed track, and it was told that feed tracks should not be unnecessarily long to make use of the space optimally. Second very important point that we discussed is that the feed track, apart from passing the parts or transmitting the parts from the ball feeder to the assembly machine, it should also act as a buffer stock. If anything happens or any stoppage happens in the ball feeder, so that the parts can still be available in the feed track, so that the machine does not starve. And the third point that we said, that is the feed tracks, they also we did not mention that the feed track should not be unnecessarily expensive as well. After that, we have discussed some escapements. These are the devices we said that when the parts have to be fed to the assembly machine one by one. So, there are certain natural devices we have seen. For example, I will show it once again. So, you can see that these are the natural devices, I am just summarizing them. These devices are activating the escapement. Okay. Escapements are being activated by the parts and the work area, but in the actual escapement, the idea is that the escapement will activate the parts and the work area, so that one by one the parts could be fed to the assembly machine. We have shown some of the examples of the escapement. For example, here it was a ratchet escapement. It is for releasing of one part at a time or more than one part by using a pawl which is pivoted here and which actually goes to and fro. So, this is the arrow which is shown, which is the direction of movement of the pawl. Now, here is another example that have been shown, that using these kind of pawls or these kind of mechanisms, one can pull it to and fro, okay, pull or push to and fro, and the parts will be taken from the feeder, delivered to the machine, assembly machine one by one. Well, let us see the other examples. For example, in this case, slide escapements delivering into single feed chute. Here these are the parts coming from the feeder, either it can be a horizontal feeder or it can be a vertical feed delivery, and the parts, when it is coming at the end of the feeder, there is a cross slide here, and this slide can reciprocate. While reciprocating, while the slide is going to this side, it will take one part from the feed track and it will deliver to the machine. So, this is going to the assembly machine. So, while it is delivering one part to the assembly machine, the other parts in the feeder will be held back. So, they will not be able to fall, and then again when the cross slide is going to the right side, then all parts will be falling up to this, and the size of this cross slide accordingly made according to the parts, so that only one part can be selected and the one part can go into the machine. So, for more than one part, depending on the thickness or the size of the part, it can be made in this way. For example, in this case 3 parts at a time will be fed to the delivery chute. So, in that case, the height of the cross slide or the width of the cross slide is made in accordingly, either to be fed one part or more than one part can be fed. Slide escapements operating several feed chutes. Look at this, from the feeders the parts are coming in this way, and here there is a slide where it has the grooves for the parts to be nested, and these groups are made according to the size of the part, so that only one part can go to that groove. So, as you can understand, this is also self explanatory, that as the slide is going to the right side, it will subsequently take up the parts from the feeders in the groups, and when the slide is going to the left, these parts will be coming one to this, another to this slide feed chute, and the third to this feed chute. So, as you can understand that depending on the requirement, it can be number of parts can be fed taken from the feeder, and this line diagram is quite self explanatory. So, this is for spherical, cylindrical or plates, for example, this kind of escapements can be used. So, again let me remind you why this is called the escapement, because when from the feeders all the parts are coming together, they cannot go directly to the machine, because machine cannot take all of them together. So, this is the kind of a mechanism which is used, called as an escapement, to feed the parts from the feeder one by one, and all these other also you have seen. One point here you can actually note down, that these parts, when they are coming from the feeder and with the help of these balls, when the parts are being fed one by one, of course, there should be some gap between the parts, so that the balls could actually penetrate, otherwise they cannot segregate the one part from the other part. So, there are certain kind of chamfers made, so that the ball can go into that groove or the space, and they can segregate one part from the others. The next escapements you can see from here, for example, this is an example which is the slide escapement, supplying 2 or more delivery chutes from a single feed chute. Look at this example here, what we are saying is that there is 3 from the feeders, the 3 parts are coming in this example and delivered to 3 feed chutes. In this example, what we are doing is, when we are taking from the feed track, from one feed track, and it is being delivered to once to this feed chute and another to this delivery chute. So, how it works, it is also quite explanatory, self explanatory. This slider, this has 2 groups, one in here, one in here. While it is coming from this side, while it is going to the left, for example, this will be collected, the parts will be collected in groove 1 and groove 2, and then when it is going to the other side, the parts from this will be coming to this groove this chute, and this part will be coming, another part will be coming to the another chute. So, that means from one feeder subsequently you can put in one delivery chute once and in the second delivery chute next. So, parts fed from a single feed track to be equally divided between 2 delivery tracks, useful where 2 identical parts are to be used particularly. So, parts are being supplied alternatively to the delivery chutes. Once it is one part is going and the similar part is coming to the other delivery chute during the movement of the slide. Here, for example, if it is 2, so more than 2 can be also supplied. Here it is another design is given, supplying parts simultaneously to several delivery chutes, and the diagram is again self explanatory, that from the feeder the parts will be collected to this groove in the movement of this slider in one way, and while it is coming to the other way, these parts will be delivered to the chutes, to the delivery chutes. There is a compression spring given here, and that compression spring helps the arm to move to and fro. Okay. Now, here is another example of an escapement which is called the drum escapement, and in the drum escapements, parts fed and delivered side by side, in the sense that from the feeder it is coming to the escapement, to the drum, and the drum is inside, which is rotating inside a casing. This outer casing is a stationary casing. So, in the drum we have the groups here, all right, and these groups can nest the parts which are coming from the feeder. So, if suppose the drum is rotating in the anti-clockwise direction, so while it is aligning with the feeder, the parts will be nested to this groove of the drum, and while rotating further and as it is being aligned to the exit, the parts will be stripped off the drum and it will come down to the delivery chute. Drum is mounted vertically and the parts are fed and delivered side by side. Okay. So, this is another advantage, and also this drum escapement also is used for using the space, where the space between the ball feeder and the machine is limited. On passing through the escapement, the parts can be turned through a given angle. This is another advantage of the drum escapement. Now, here this is another principle, parts fed end to end, all right, and delivered side by side. So, it may so require that parts are coming in a certain position, and the machine that the assembly machine will accept the part in another position, for example. Okay. So, here for example, the parts are coming like this, parts are coming end to end and they are delivered side by side, and this is again the example of this, and this is the rotary side escapements, which is the example shown here. This is similar to this. Okay. Next is the star wheel and the worm escapements, and these are also given, the diagrams are here, you can see this, there is a star wheel here, and this is the feed track. Now, inside the feed track there is a space here through which the star wheel can rotate, and while rotating the distance between the teeth of the star wheel is made in such a way that it will actually grab one part and then deliver, while the other parts will be held by the other teeth of the star wheel while it is rotating. It rotates at a very lower speed, the speed which is required for the machine to be, for the parts to go to the machine. Now, direction of motion is unaffected by the escapement, that is one thing. Parts should have suitable gap between the outer edges. Here by virtue of this size of the parts, okay, that means the shape of the part, that is the round shape, you can see that always there will be a space for this star wheel tooth to go in and then segregate the other parts, and one part can come to the assembly machine. Here there is a worm, okay, like in case of worm and worm wheel. So, this worm rotates again inside the some portion of this worm will go inside the feed track. There is an opening here, and the teeth which are these teeth which are of the worm, when it will rotate, they will actually take the parts one by one to the machine, because this is rotating, let us say this is rotating in this direction, and then parts will be guided by the space here and it will be taken to the machine, assembly machine. Now, these worms, if it rotates continuously, for example, then the speed of the feeding of the parts will be too high. Okay. So, therefore, this is rotated intermittently as and when the when the part will be required for to the machine. So, depending on the cycle time in the machine, for example, if it is an assembly machine, so how much time it takes for making one assembly of one part, let us say it is 5 seconds. So, it will stop for 5 seconds, after 5 seconds it will again take another part, so that the machine can accept. That is what we mean by driving this intermittently. This is one example of the jaw escapement, and the jaw escapement works in the following way, that we have the actuator, which is a punch also, and here there are poles. Okay. So, it is actually when the parts are coming, let us say in this figure you can see that from the feeder the parts are coming like this, and the actuator can be also used as the escapement, as well as when it is required to push, for example. Let us say for push fitting or for riveting, for example, used when some forming process is necessary on the parts after it has been placed in the position. The positioning is done one by one from the feeder by this punch, and then it can also work further to push it to make some to impart some forces, so that either it goes in or it is push fitted or it is riveted, for example, if it is required, and so on. So, this is given, this is called the jaw escapement, and it works very well. So, here in this diagram, as you can see, that this is the escapement, and the actuator comes, releases this part from the escapement and then doing some forming work, that means imparting some force if it is required. I hope this is clear. By far the most widely used parts placing mechanism is a conventional gravity feed track working in conjunction with an escapement. This system of part placing is probably the cheapest available. Example I have shown it to you earlier, all right. So, those are the conventional gravity feed tracks in conjunction with an escapement. Now, it has certain limitations, and those limitations are, it may not be possible to place and fasten parts at the same position on the machine because of interference between the feed track and the workhead. This would necessitate a separate workstation for positioning the part, which would result in an increase in the length of the machine. It then becomes necessary to retain the part in its correct orientation in the assembly during the transfer. So, these points have to be kept in mind, because these are the important things, that whether you are going to have the what kind of part placing mechanism you should have, what kind of escapements you should have, and so on. If a close fit is required between the part and the assembly, the force due to gravity may not be sufficient to ensure that the part sits properly. This example exactly means that suppose you are putting that in the place, and it is not enough that with the gravity it will go into this, into the position. So, there you may need some kind of force from outside to impart on the part, so that it can actually be placed here. Otherwise, also what may happen is that part may be misplaced in the position, it may be wrongly positioned. Okay. So, that is another thing which will be which can make a faulty assembly, for example. If a part cannot be suitably chamfered, the gravity feed track may not give the precise location required. So, if they are chamfered, that is fine, it can be, but not all parts could be chamfered, and in that case the gravity feed track alone cannot actually work. So, there have to be some kind of a part placing mechanism. Okay. Apart from the escapement what we have discussed, their job is to put the part one by one to the feed the part one by one to the machine. Okay. Here what we are talking about, that some of the gravity feed tracks along with the escapement, that may not be enough for the parts to put in a right position. So, for that we need normally a part placing mechanism. Let us see what are the part placing mechanisms. Normally they are the manipulators, they are the robot hands, and so on. However, look here, this is the diagram which is showing the screw placing and driving. See, here in this diagram what is shown is that from the feed track the parts are coming in here. So, this is the jaw, or this is the screw drive, for example. This can go up and down. So, while going up to this position, it can allow the part to come in, one part to come in. The space can be such that one part goes in, and then after that this screwdriver, it can be a screwdriver as well. So, this can go in and it can apply some torque, so that the screw can actually go inside the threaded hole. So, both these two working conditions are shown here. For example, here the part is placed, okay, and there are jaws here, so that the jaws could be acted as an escapement, and after that the screwdriver comes in and it rotates to impart the torque to this. So, for placing of screws and rivets which together form a large proportion of all part placing requirements, and where the tool activates the escapement and applies the required force to make assembly possible, the gravity feed track is invariably used. So, all these in all these cases the gravity feed track is used. Another part placing mechanism or other part placing mechanisms, as I said, that this kind of robotic arm or manipulator can be used. So, in this, part is picked up from the feed track by means of mechanical, magnetic or vacuum hand. So, this is the manipulator or the robot arm, and it has at this end effector. It can be a mechanical gripping, or it can be a magnetic if the parts are of ferromagnetic material, or it can be a vacuum hand. For example, if the television screens are to be picked up, or if a very precise plate should be picked up where you cannot afford to have any kind of gripping, so that there is no scratch or anything, okay, or computer screens for example. Okay. So, from the feeder the parts are coming here, and it will the robot manipulator, it will come like this, then the end effector will come to this position, pick it up, go up, and then again going to this side and putting it in the work area. So, it will pick up from the feeder and it will place to the work area. That is the part placing mechanism, the job of the part placing mechanism. Picks up job vertically, transfers along a straight path and horizontally, and place vertically again. So, this kind of movement can be programmed, so that all the time it will move like this, come here, go up again and come to this position. So, it can actually repeat this position. So, they are normally programmed, so that the parts can be placed one by one from the feeder to the work area. Here is another example using the same using the robotic hand, but that manipulator is of different configuration. For example, this is the manipulator like in here. So, here this manipulator picks up the part from here and it rotates and placed it here. In this case, what is happening is that the work carriers and the feeders, in this case it is side by side, and the mechanism is behind the work carrier. So, it may so happen that the mechanism is placed in between the work carrier and the feeder. In this case, it will take up the job from the feeder, this hand will rotate about this axis and it will place it vertically to the work carrier. Picks up job vertically, transfers around the arc of a circle in horizontal plane and places vertically. So, this is the idea, and this is the working principle of the part placing mechanisms. These are simple mechanisms, pick and place units, and those units can be placed either behind the work carriers or in between the work carrier and the feeder, as I said. Now, the signal when it has to activate, this may come from the machine itself, from the assembly machine itself. Assembly machine, when it finishes a work, sends a signal to the pick and place unit, and then it will activate and bring the part from the feeder to the work carrier. Here are some other examples of the part placing mechanisms. The diagrams, as you can see, they are self explanatory. Here the picks and here picks and places by rotary motion of the transfer arm in a vertical plane, and throughout transfer the hand remains vertical. See, here we have the feeder, the parts are coming from the feed track, and this is the pick and place unit. Here we have the manipulator. This is pivoted here, in the sense that it can this arm can rotate about this pivot, about this point, and here there is a manipulator. This manipulator can also rotate like that at a 90-degree angle, all right. So, what it does is that this arm will rotate, this manipulator will pick up the part, and then again it will go to this position and then place the part vertically. So, here you can understand that it may actually have two movements, one movement will be by this and another movement will be by this. So, there are two degrees of freedom here. Here is another example, like pick and place unit is here. This is the work feeder and parts are coming from the feeder and to be placed to the work carriers. So, here also like in this design we have the manipulator which can actually rotate about this point, okay. It can swivel around this point, and here this arm can also swivel about this axis, all right. So, that if the part is taken from the feeder in one orientation, it can turn the part and put the part in another orientation. So, it is like it is taking like this and putting it in this way. So, this is the idea of the of this part placing mechanism. The part is turned over during the operation, suppose if it is so required. So, in this case this kind of part placing mechanisms are used. Here I will come back to this. In this case the part can be placed in the same position as it is picked up. Here the part is turned from the position it is coming. Next we will discuss some of the points in the design for automatic assembly. Now, when we are having the automatic assembly, it is understood that since the human being is not involved there, so some of the jobs that the human being can do very easily may be very difficult for the automatic assembly to perform or automatic machines to perform, and therefore, some of the points we should consider in the design of the part when we are designing the part, so that the automatic assembly could be done in a better way without the intervention of the human being. I will give you some examples. Suppose you have a part which is of a very complicated shape, and there are several of them, they have to be assembled. So, in that case what is happening is that we require several machines for performing each of these assembly operations, all right. Whereas, we can change the design in such a way that some of the parts could be combined together in the design to make one part out of those, in the sense that suppose using developed let us say metal forming processes or metal casting techniques to join some of the parts and make it as one part. So, that if we have two parts joined together in the design, in that case two assembly processes could be avoided and there would be only one assembly process. So, therefore, for design for automatic assembly, two aspects will be required. One is the product design for ease of assembly. As I said, for example, product design for ease of assembly, chamfer is one thing which we have discussed earlier, which actually facilitates the facilitates the parts to get assembled. Okay. And there are many other aspects that we will see in the subsequent discussion, that the product design should be for ease of assembly. Another aspect is that design of parts for feeding and orientation. It is not only that we are assembling the part, but we are also feeding the part. So, in the design we should consider some of the aspects, so that the feeding could be done in a proper way as well as the part could be assembled in a proper way. These things in details we will discuss in the next session. Thank you very much.